Alright, welcome to 5.2 lesson. Today the learning target is to solve systems of linear equations by graphing or using the calculator. Okay. So what is a system in algebra? A system of linear equations is just when you have two or more equations. So if I have two or more lines, it's considered a system. Okay, so you can have three different scenarios here. You can have lines that never touch, parallel lines. You can have intersecting lines. Or you can have two lines on top of each other, which we call coincidental lines. Parallel lines have no points in common. Intersecting lines have one point in common. And coincidental lines have infinite points in common. So when we're dealing with parallel lines, there are no solutions. When we're dealing with intersecting lines, there's one solution, and coincidental lines have, since they touch everywhere, they have infinite solutions. The solution here doesn't exist. I'm going to put an empty set of brackets. The solution here is x comma y, that point. And again here, the solution would be infinite. So we did this word problem last lesson. The equations were x plus y equals 33. X was the number of grocery on list 1. And y we can call number of items on list 2, number of items on list 2. Okay. These are our two equations. If I solve for y here, I get y equals x minus 7. So that's what we're going to graph. And if I solve for y here, I get y equals negative x plus 33. So I got one line going up, one line going down. Okay, so if I solve this by graphing, move it over a little bit. So let me graph this first. So the y-intercept here is 33. And the slope is negative 1. Let me make sure. Yep, okay. So down 1 over 1. Okay, I'm going to use my straight edge here to graph it. Maybe with a pencil to make the line thinner. Okay, here's my first line. And then I have this other line here. It starts at, my y-intercept is negative 7, so 1, 2, 3, 4, 5, 6, 7. And it goes up 1 over 1, up 1 over 1. Okay. Now I have to look at the point where they intersect. So the thing is, with graphing, you have to be very, very precise. So it seems that's the point. So if you look at that point, it's right 20 and up 13. So 20, 13. Okay. I could have also graphed using my calculator. So remember, always use documents, not the scratch pads. So I had negative x plus 33, and I have x minus 7. Okay. If you notice, the blue line didn't appear, and that's because I'm zoomed in too much. You can move over the screen. I'm going to zoom out a little bit around here because I know where the, okay, so we found the intersection there. Now there's many ways to, if you're going to use the calculator, you can click Menu, Analyze Graph, Intersection, and you want to click to the left and to the right, and it finds that intersection for you. And you can see it's 20,13, the same thing I got over here. So let's write some steps here. So after I graph equations, and then you want to do Menu, Analyze Graph, Intersection. Okay. To zoom in, it's Menu, Window Zoom. To find intersection, you need to click on both sides of the intersection. And we'll do another example in the calculator so you can follow along. Okay, so my solution is going to be 20,13. Now they're asking me for the number of items on list 1, so I have to go back and see what I defined as list 1, and that's x. So there are 20 items on list 1. Okay? Another way of solving these is actually using the calculator, not the graph. So let's do that. So I'm going to do Control Doc to add a page, and I'm going to add a calculator. So and it's going to be Menu, Algebra, Solve Systems. So Menu, Algebra, Solve Systems. Okay, then they ask you how many equations. We had 2. Our variables are x and y. Okay, and then enter Menu, Algebra, Solve Systems, and then enter both equations. So I had x minus y equals 33. The nice thing here is you don't have to solve for y on this one. No, sorry, that was x minus x plus y equals 33, and then x minus y equals 7. Okay, and again you get the same. So you enter both equations. Okay. And it gives you an answer. Okay, so far so good. Alright, so let's do some more examples. As you can see, it's pretty straightforward. Graph them, find the intersection. So let's look at another example. Oh, and back here, I forgot. Didn't get print right, but number of items in list 2 was 13. That was our y. Okay. The hard part, I guess where you could make errors is when you create the equation. So let's look at another situation here. We've also already done this one. A rectangular field is 12 feet longer than it is wide. So I have 2 variables here. X is going to be my length, and y is going to be our width, are both in feet. Okay. So it's 12 feet longer than it is wide. So the length is 12 longer than the width. And the perimeter, if I add all sides, I get 76. Okay, so again, let's solve it by graphing. This time I'm going to graph using relation. I want to see if we can...
Just please pardon this interruption.
Alright, back over here. Let's see if we can use relation to graph this now. So I have to solve for y. Let's see if it lets me find the intersection. So 2x plus 2y equals 76. There's the line. And x equals y plus 12. Alright, so also if somebody called y the length and x the width, right, you're going to get the same answer, but they're going to be flipped, right? So you have to know, that's why it's important to write out what to define your variable as. So menu, analyze graph, find the intersection. So this happens sometimes, and I don't know why, but if you notice, now it's not asking for you the left, the lower, and the higher side. It's actually asking you for the first corner. So you have to create a square using the your cursor there. So you click once, and then you make a square, and then you click again. So you gave me the intersection. It's 25, 13. Okay, or let's use parentheses. So 25, 13 is my intersection. Okay. And I'm just going to make so this line comes from under there. You can't put the y-intercept because it's negative 12 and it's down there. And then I have this. I'm just sketching. It's not really accurate here, since the calculator gave me the... Okay, so graph equations. Zoom if needed, but we didn't zoom. So window zoom. You can zoom out, you can use zoom fit. Okay, find intersection with menu, analyze graph. This time we had to make a square around. So I'm going to make square here. We made a square around the intersection. Okay. So since I defined x as my length, it's 25 feet, and my width is 13 feet. Okay. So using our other method, or let me just, I already have a calculator page, so I'm going to do menu, algebra, solve systems, menu, algebra, solve systems. It's a good idea. I don't think we're ever going to have to write it again. We're just getting you guys used to. It's good to write it out, so maybe it will help you memorize it. Menu, algebra, solve systems, enter equations. So I got linear solve, and it looks like 2x plus 2y equals 76, and we have x equals y plus 12. I click down, not enter. X equals y plus 12. Okay, and we get the same answer. So now you get to use whatever method you want. Okay. So try number 3, and then, well, actually, go back to your notes. You already have these equations. So define your variables and solve for what they're asking. So I'm going to pause, and then when I come back, the solution will be on the... Alright, so hopefully you had enough time to work the solution. You should have pressed pause, right, so you can work these problems yourself before just writing down the answer. So I used the calculator method. So I put in menu, algebra, solve systems. That's the method I use. You always want to start the problem by defining the variable. So I got X is the price of student tickets and Y is the price of adult tickets. I plugged both of these in, and the calculator spat out 6 and 14. Alright, so it's $6 for student tickets and $14 for adult tickets. So that's what they're asking up here on the next page. Price of adult tickets is $14 and student tickets is $6. This question is going to be on your exam, so make sure you pay attention to that. Okay. This example is the same thing. So let's do that one. Maybe we'll do that one by graphing. So the drama. So let's see. The drama club is selling tickets to display. The cost of adult tickets is $450, and the cost of student ticket is $250. The theater can hold 250 people, and they want to make $1,005. How many adult tickets must they sell? Okay. A hint to defining your variables. On the question, the questions help you define your variable. So, how many adult tickets must they sell? So that's going to be one of my variables. So, number of adult tickets. Now it's not the price, it's the number they sold. And number of student tickets. Okay. So it can hold 250 people, so that means this has to be less than or equal to 250, but since we're not doing inequalities, we're doing equations, I'm going to say it's equal. And they want to make $1,005, so 450 times the number of adult tickets I sell plus 250 times the number of student tickets must be equal to 1,005. Okay, so let's do this one by graphing, and I'll let you practice and put that in the calculator. So you should pause the video now so you can try to put this in the calculator yourself. Okay, so menu, I'm gonna go back to my graphing page, clear everything, click delete 3 times. So let's enter our equations. It's already in relations. X plus y equals 250. And I got tab 450 times y plus 250 times x equals 1,005. Okay, we can't see anything, so I'm going to use the zoom. I'm going to use zoom fit, see if that works for me. Almost. So menu, I'm going to zoom out around here. Okay, so I found the intersection there. And I'm going to do menu, analyze graph, intersection. And this time it's asking you to click on the left, and then I don't know why it does that sometimes. Sometimes it will ask you to make that square, as you saw. Okay, this time we graphed, right? So graph, and then do menu, analyze graph, intersection. So X was the number of student tickets, so they sold 60 student tickets and 190 adult tickets. I'm going to double check my equations. Okay, that looks good. Okay, so these are not word problems, they just give you both equations. So here I have a system, right? 3 systems of equations. So the best way to do these, I would say, is using the calculator. So menu, algebra, not numerical solve systems. And I'm going to plug these in. So I got negative 15x plus y equals negative 24. Negative 5x minus 3y equals negative 28. Okay, so this solution was 2 and 6. The point 2, 6. So if I was going to just to visualize that, right? And I'm just going to draw 2 lines here, just to represent my. Okay, these are not accurate. I'm just drawing 2 lines to show they intersect once. Okay. Okay, so let's type in our other 2 equations. So I got y equals x plus 1. And I can see their slope is the same, and you should know what that means if slopes are the same. That means they are going to be parallel. So there's no solution for this one. And to represent that, this one can actually be accurate. So I got here, and their slope is 1. I got here. Okay, so parallel lines. Again, those are not perfect, but it's okay. Okay. And last one. Okay. 5x minus y equals 12. 10x minus 2y equals 24. I don't know what happened there. Oh, I mistyped. I put 1x instead of 10x. So let me go back. It's always important to check your work. After you type something in, go back and make sure you did everything correct so that your answer is correct. Okay, so I get a bunch of weird things here. Okay. You get different numbers every time when you do this. But if you get something weird with variables in it, if you look here, we are showing every scenario. There's intersecting, parallel. So this is going to be our coincidental lines. Okay. So this one is actually infinite solutions. So I'm going to use 2 different colors here just to show that they're on top of each other. Okay. Alright, so basically you can do the whole unit using the calculator. So good luck on the practice, and come to tutoring if you have any questions. Thank you.